Hi students, I'm going to introduce my model of labor supply, and it's basically the trade-off, say Leo has here every week. When he wakes up, he has to decide how much he's going to go to work and how much he's going to do other things, which I represent it here as NPA, non-paid activities. Okay, our non-paid activities could be taking care of family, kids, or elders. It could be doing other hobbies that you don't get paid for. Okay, that's what we have along here. We measure that along the x-axis, how many hours are spent doing those activities. Okay, now when you're doing those activities, you're not getting paid, so you see the income here is 0. Okay, if you take 10 hours away from doing non-paid activities, you can work a little bit. All right, the more you work, say you work all your money, you can work all your hours, you could earn a high income, but you wouldn't have time to do those other non-paid activities, such as spending time with family. So one way of looking at this is there's a trade-off. You can earn more and provide more for your family, or you could spend more time with them. It's very, very hard to do both. All right, to set up this model, we have to know 3 pieces that are given. The first piece is how many hours do we have in the week to either work or do these activities? Okay, so T here, our time, equals 80 hours. So 80 hours in the week, we can either put all that into work or all that into these other non-paid activities, or we can split it up between the two. Of course, there's more hours in a week than 80, but we assume that other time is spent for necessary type things such as sleeping and things like that. The second piece we need to know here is V. And V represents the non-work related income that we get, say, at the beginning of every week. So Leo wakes up Monday morning, and if he's getting positive amounts of money, say from his parents, he could live on that and not have to go to work. I wanted to make a more realistic situation here and say that V is equal to negative $100. Okay, V is equal to negative $100. Likely because, for example, I'm still paying college debt. Every week I wake up, I'm in that debt, I have to pay it off. So that we start off in a hole here with the college debt. And the third piece we want to know is, what is our wage? Okay, Leo wakes up, he has a job. What wage is he making? Well, he's making $20 an hour. So we'll begin with that. And then I have an additional piece of information that we'll talk about in just a moment. All right, so first we need to know, let's look at the 2 extremes that Leo could face. He wakes up Monday morning. On the one extreme, let's say that he spends all of his time in non-paid activities, be that playing video games or raising his kids. So he's going to be basically working 0 hours or spending all of his time in non-paid activities. So that whole 80 hours is going to be spent all in non-paid activities, just to begin, okay? We want to see what that is going to look like. So if he's spending all of his time in non-paid activities, how much income is he making? Well, he's not making any working, okay? But he is in debt, right? He's in minus $100 debt, okay? So the first point of this, what we'll call it our budget constraint or our time constraint, if Leo spends all 80 hours in non-paid activities, he's going to be in the hole minus $100 right here. Okay, here's minus 100, here's 80. That's the first point on this. We're going to call this our endowment point, E1. Okay, our endowment point represents when you don't work at all, how much you're either making positive income or negative income. Since this person's in debt, he's making negative. Okay, so that's the first point. Now we want to look at the other extreme. Okay, if one extreme is you work 0 hours, well, what if you worked all 80? Okay, so if you worked all 80, you'd be making kind of a max income. And I apologize for my writing on this, but our max income point. Okay, our max income point. So let's think about this. We'd be working 80 hours, right? Okay, if we put all 80 hours in, we'd work 80 hours. And at each hour, we'd make $20 an hour. So 80 times 20. So for that week, we'd make $1,600. Okay? Well, we're not done because you always have to pay off that initial debt. Okay? So that's minus 100. So our max income would be 1,600 minus 100, or 1,500, or it'd be this point right here, okay? Because we'd be spending all 80 hours, not in non-paid activities, but in paid activities. So the more you work, let's put this in a different color. The more you work, you move this way on the graph, because this represents work time. Work. Okay? So if he's working all 80 hours, that means he's not spending any time with his family. Okay? So he's working all this time, and he'd be making $1,500. All right? So we have 2 points. The endowment point, which is not working at all and spending all day in your hobby, versus the max income. So let's link these two together. This line. So this is my time constraint or my budget constraint. All right, so we'll just say this is budget constraint 1. Okay. The last piece we want to do is, where does he start off at? Well, he begins working 40 hours a week. So let's take a look. Let's tell where he's at right now. His current work situation, or his current decision. Okay, so he's working 40 hours a week, as I indicated right here. He makes $20 an hour. Okay, 20 times 40 is 800. And he has to pay that $100 in school fees. So he's currently at $700. Okay, he's making $700 and working 40 hours. Well, how we figure this out is he's going to work 40 hours. So you start off with the ability to not work at all, but he's working 40 hours. So 80, so he works 10 hours, so he has 70 to play. 20 hours, he has 60 to play. 30 hours, he has 50 to play. Or if he works 40 hours, that means he's working 40 hours, and then he has 40 hours to play. So at 40 hours, he'd be making approximately $700, which is going to be right here. Now, since I put this using my budget information, this is going to be this point on the graph right here, and I'm going to call this P1. Okay, where when he works 40 hours a week, okay, he worked 40 hours a week, and he's making approximately, I did that a bit too high, he's making $700 a week. Okay. The last thing I want to point out that we want to know is, what does the slope of this budget constraint represent? Well, it represents what we call the opportunity cost of our non-paid activities. Let's say Leo, his non-paid activities are spent playing video games. Okay, the opportunity cost of video games is what he loses when he's playing those video games. For example, if he were to play 10 hours of video games and not go to work, because he has that decision here, okay? If he were to play 10 hours of video games, he'd only get to work at 50, okay? He'd move back this way playing video games. So his income would now be here, right? Let's call this P2. Here he's working 30 hours, and he'd be playing video games for 50 hours. Well, how much income would he lose? Well, he'd be working 30 times 20 is equal to 600, minus 100 is equal to 500. Okay, so this would be 0.12 is working 50 hours and working 30 hours and making $500, and playing video games for $500. So what has he lost? Well, he got plus 10 hours of video games from P1 to P2. So that's P1 to P2. He got plus 10 hours of video games, but he lost $200 in wages, in income. Okay? So per hour, he lost minus 200 per 10, and that's equal to minus $20 per hour. Okay, he lost $20 per hour. Okay, this is the opportunity cost of video games for Leo. Minus minus 200 over 10, which is equal to $20 an hour. The opportunity cost, have we seen $20 an hour? Yes. It's his current wage. Okay? So the opportunity cost of video games for Leo is equal to the wage.